Hey, it's a designated driver here. Pull up a seat and I'll pour you a cup. And if you stick around long enough, I'll spill the tea on number 2 on this year's AP exam. This particular problem, they're giving us a t-table of values that represent the velocity of some particle. A wants us to justify why. Is there somewhere where the velocity's derivative, better yet known as the acceleration, has to equal 0 in the interval from 0.3 to 2.8. Now, this is going to target the mean value theorem. The mean value theorem stated, let's go back over that. If a function is differentiable on some interval, a to b, that's my a and b in this problem, then it guarantees that there is a spot inside this interval where the derivative equals f of b minus f of a all over b minus a. Okay? So we know what interval we're looking at in this particular problem. So what we want to know is, first of all, let's find f of b minus f of a all over b minus a. So I'm going to be doing f of 0.3 minus f of 2.8 all over 0.3 minus 2.8. Now notice my y values at those two spots are both 55. So 0.3 minus 2.8. The top is just going to give me 0. On the bottom, I get negative 2.5, and that reduces to 0. So by the mean value theorem, I know the derivative is going to equal this number somewhere in that interval. And because it's differentiable, the directions say that your function is differentiable. Differentiable implies it's continuous. So yes, that is true by the mean value theorem. B is a common question they like to ask on this t-table, a Riemann sum or a trapezoidal sum. What they want us to do on B is to approximate the integral from 0 to 2.8 of the velocities. So we're using 3 subintervals, so that means I'm going to have 3 trapezoids. So let's recall, the area of a trapezoid is 1/2 times the base times the sum of my heights. So since we're doing 3 subintervals, that means I'm going to have 3 trapezoids, basically 3 cases. So for my first trapezoid, if I notice the width of my interval, I'm going from 0 to 0.3, so that would be a width of 0.3. And then all I do is add the y values at those endpoints of that interval. So that's 0 and 55. So that would be the area of my first trapezoid. Now, I'm doing 3 intervals, so that means I need 3 areas. So my next one, again, 1/2 is always in there. The width of my second interval, I'm going from 0.3 to 1.7, so that would be 1.4. And then I add up my y values again. So that's 55 and negative 29. And my last one, my width of my last interval, I'm going from 1.7 to 2.8, so that's 1.1. And then again, I add my y values, so that's negative 29 plus 55, and that's going to give me my 3 areas. So my final answer, I'm going to add up all 3 of these areas to get my estimate. So let's bring up the calculator. All right, guys, part C, they give us a new velocity equation of some new particle Q. And what they want us to do is find out where in the interval from 0 to 4 is the velocity of this new particle at least 60, which means 60 or more. So what we can do is find this pretty easy using the graphing calculator. So let's bring that up.
Okay, so what I want to do is I want to find out, remember, where this equation, which I've already typed in, my velocity equation, is at least 60. So my second equation I typed in was 60. So if we pull up the graph, what we'll see is my blue function is my cosine graph, and then the red is my line of 60. So my window is 0 to 4, and we can see that at least 60 means 60 or greater. So what I'm looking for is this portion of my cosine graph, this portion that's above this red line. So I can find that by going over to calculate and doing option number 5, which is intersect. I want to find where these two equations are intersecting. So this first intersection point is 1.866, and that's where it starts. And I want to find the second one. So all I got to do is do the same application, but now I need to move this over to the second spot, and that's going to be roughly 3.519.
So according to the graph, where our velocity equation was higher or greater than 60 was from 1.866 to 3.519. So there's your answer. All right, guys, the last part, D, wants us to find the distance between our two particles at 2.8. So basically what we're going to do is find the position of both and then just subtract those values. So the first part's not going to be very difficult because the integral from 0 to 2.8 of my velocity of P is 40.75. We did that in part B. Now, I know that the position at 2.8 is this value because they tell us in the problem that P starts out at the origin. Okay, so I know 40.75 represents the position at 2.8 for P. Now, Q is going to be a little bit more difficult. So, I integrate from 0 to 2.8, but this time of my velocity of Q. All right? Now, when I integrate velocity, that gives me position. And typically position is denoted with an X. So that's going to represent the position of 2.8 minus the position at 0. So remember, I want to know what my position is at 2.8. So the position at 2.8 is just going to be the integral from 0 to 2.8 of my velocity of Q, which we know from earlier is 45 times the square root of t times cosine of 0.063 t squared, plus my initial position. So again, this problem is with the calculator, so I can find this integral using the calculator, and they give me the position or the starting position of Q. It is negative 90. So I'm just going to integrate this function using my calculator. We do not want to do anything by hand if we don't have to. And then all I'm going to do is add my negative 90. So let's pull up the calculator and find that answer. All right, guys, I got a value of 45.937. This is the position of Q at 2.8. So remember, what do I want to do in this problem? I want to find the distance between those two. So now I have the placement or position of both. I'm just going to subtract those values. And my final answer is approximately 5.188. 3 decimals. Well, that about wraps it up for today. Make sure you... I just spilled the tea.